Okay, the next one is about parallelized hybridization. So what is parallelized hybridization? We will look at three different methods: weighted, switching, and mix. So in the parallelized hybridization design, we want to see the output of several existing implementation combined. We have input, we will do the recommender 1, we will do recommender 2, we will do recommender n, and then we will combine. And after we combine it, we will do the hybridization step and then show the output. So we call this method is least invasive design. And this design requires weighting or voting mechanism. Weights, maybe in Korean 가중치. So it can be learned dynamically. And in extreme case of dynamic weighting, it is about switching. Okay? So we can switch in extreme case. So for example, we can use the weighted. The weighted means we put weight. Let's say I have recommender 1, and then I have recommender 2. And then in the recommender 1, the item 1, we have 0.5. In the item 2, the recommender 1 give 0. In the recommender 1, for the item 3, it gave 0.3. And in the item 4, it gave 0.1. Item 5, it gave 0. In this case, you can make a rank. What is rank? 순서대로. We can make the order. This is the first. So this is the first. This is the second. This is the third. For the recommender 2, we can also see its result of the prediction. For example, in the item 2, it shows 0.8. In the item 2, it shows 0.9. Item 3 shows 0.4 and 0 and 0. So we can make the hybridization by giving the weight. For example, I want to give the weight 0.5, 0.5 for recommender 1, and 0.5 for recommender 2. Then 0.5 here multiplied by 0.5 plus 0.8 multiply 8 multiplied by 0.5, which is the weight. Then you will get the value like 0.65. This will be the new numbers for the item 1 after we have the recommender 1 and recommender 2. So just simple weighted. And of course, we need to make sure that the total weight should be equal to 1. So this is the weight. The total weight should be 1. So if it is 0.5 and 0.5, then the total is 1. This is the weighted method. But yeah, how to derive weight? Weight is very trivial. Okay. Sometimes we need to use some estimation. Maybe we use empirical bootstrapping, or we can use some dynamic adjustment of weights. in this case, yeah, if we use the empirical bootstrapping, we need to get some historic data. If we have some historical data, then we can use which one is more important than another item. Or we can try to compute different weight and look at the optimum result and decide which one does the best. If we use the dynamic adjustment, it means we want to start, for instance, uniform weight distribution. Uniform weight distribution is just 0.5 and 0.5. For each user, adopt weights to minimize error of prediction. So if you use 0.5 and 0.5, try to look at the error. The error, we can use MSE, or we can use the RMSE, or we can use the MAE. Okay. And if the error is minimum, okay, we can use that particular weights for the hybrid. Now, this is another example. Oh, sorry. This is, I think, the same with the previous one. So if we have the score 0.5 for the item 1, and we have the score 0.8 for the item 1 from the recommended 2. This is from the recommended 1. Then in order to get the hybrid, we just assume that the weight is 0.5. Then we will do this recommender system with the hybrid by multiplying the weight and the score, and the weight and the score. So we get the new weight, which is 0.65. And then we can also do with another score. After we have all the scores, we can do the rank. And if you look at this rank, at first, the item 1 is in the rank number 1 for the recommender 1. Item 2 is number 1 in the recommender 2. But when we do the hybrid techniques with weighted, now item 1 becomes rank number 1. So there will be some changes. Okay. Maybe the recommender techniques is different, so it gives different result. And usually we will just use the hybrid techniques. This is more objective because it combines several weaknesses. Let's say this one is 0. 0 means nothing. But the recommender 2 give 0.9 to items. And we want to leverage this strength, so it becomes a new number in this case. So we can also, as I mentioned to you, we can try to look at the MAE. So look at the MAE means after we have the new recommender system, then we will check the dynamic weight. For example, we just use 0.5 and 0.5. Now, how if I use 0.1 and 0.9? If I use 0.1 and 0.9, now let's take a look. I need to multiply this one, 0.5 multiplied by 0.1, and then 0.8 I multiply with the 0.9. Now let's assume, that let's assume the best one is 1. So in order to know the error rate, it means I will subtract this score with 1. So 1 minus 0.5. So you can see here the error is 0.5 minus 1. So we can make the absolute. The absolute means we want to make it as a positive. So the error 1 is 0.1, which is from the weight beta 1, multiply by the error of the recommended 1 plus 0.9, which is the weight for beta 2, multiply by 0.8 minus 1. 0.8 minus 1. So we assume that 1 is the best. So the error is 1 minus the score. Okay, the score is 0. The score error is 0.23 from this one. And then let's assume we want to check with item 4. Okay, so in the items case, there are not only item 1, but there might be another item. Let's say I want to measure the item 1 and item 4. So item 4, we have the score is 0.1 and the score is 0.0. Okay, if you look at the error here, then yeah, the error is 0.99. By looking at this one, okay, we can have the average error is 0.61. In this case, if we use this beta, okay, if we use this weight, the MAE is 0.61. Now, let's do with different weight. With 0.3 and 0.7, we got this MAE. With 0.5 and 0.5, we got this MAE. With 0.7 and 0.3, we got this MAE. With 0.9 and 0.1, we got this MAE. Then we can select the least number of MAE. In this case, we can say that using this weight is the best because it provides the least MAE score. Now, the issue is when we look at the score, it does not represent the rank. What does it mean by the rank? Rank means when we have this score, we need to look at what is the best item according to the score. This is the first, this is the second, this is the third. But in the recommender 2, item 4 never get a chance to be in the rank. So it is 0. And this thing, we can say that maybe, that's one of the reason this one is better. Because when it is 0, so it give a high weight here, so the error rate is lower. So that's another possibility. So in this case, be careful when weighting. Recommenders need to assign comparable scores over all users and items. Some score transformation could be necessary. And stable weights require several user ratings. So in this case, because we only have 2, we cannot see the consistency between the scores. We can have another method, we call it switching. Switching means it requires a mediator that decides which recommender should be used in a specific situation, depending on the user profiles and the quality of the recommendation results. So we use this formula. We have, there is axis k from 1 until the number of recommenders switching of u comma I user of particular item, and it will be equals to the recommender of k of particular user and item I. Special case of dynamic weight except one is beta 0. Now, for example, yeah, this is necessary to overcome the cold start problem. Okay. So, I also want to discuss about the team project. So I received your team project proposal, but I have not finished to check the proposal. But one of the team, yeah, I saw that you want to address the cold start problem. So the switching is good approach for the cold start problem. To overcome the cold start problem for new user, maybe we want to use the knowledge base first. And then when the user's rating collected, use collaborative filtering. So we will use knowledge base, and then after that, collaborative filtering. If we want to overcome the cold start problem for new item, we can use content-based filtering first, and then use collaborative filtering. Okay. So the step is different. If we want to collect from the user, we use the knowledge base and then collaborative filtering. If we want to look at the item, we use content-based filtering first and then collaborative filtering. So there are some ways for this switching. Okay. Switching, as you know, we switch the method. Okay. So two content-based variants and a collaborative strategy are employed in order manner to recommend news article. The first, we will use the content-based nearest neighbor, because in this case there is a research about news youth. Okay. At the first time, we check the content. After we have the content, so we check the nearest neighbor recommender. So if it does not find any closely related articles, then a collaborative filtering system is invoked to make the cross-genre propositions. So the first, we'll use the content base. And then after content base perform, we use the collaborative filtering. After collaborative filtering perform, we use the naive bias. Use the naive bias. So the naive bias is just the probability. The naive bias classifier finds articles matching the long-term interest profile of the users. Mix. Mix means we want to combine the result of different recommender system at the level of user interface. Result of different techniques are presented together. So recommender system for user U and item I is a set of tuple. In this case, we have the score, comma k for each of n constituting recommenders, recommender system at the k states. So it is just the union of the recommender system. So let's take a look. In the mix strategy, there are some works like here. They use the top scoring items for each recommender and display to the user next to each other. This research used predefined precedence rules between different recommender functions. And this research merged the result of several recommender systems, for example, recommendation bundle, tourism domain obtained from accommodation, sport and leisure activity, recommender system. So yeah, we collect from several other domains to do the recommender system. Okay. The last one is pipeline hybridization. So there are two methods. We call it cascade and meta level. Pipeline, as the word pipeline, it is uh, like a pipe. Several recommenders sequentially build on each other before the final one produce recommendation for the users. So we have recommendation one, and then it goes to recommendation two, it goes to recommendation three, it then go to the output. Pipeline hybrids differs according to the type of output they generate for the next recommender. We have two, which is cascade and the meta level. Cascade. Cascade means the preceding component deliver a recommendation list to subsequent component. So in the cascade, in the recommendation one, we have list 1, 2, 3, 4, 5, 3, 7, 8, 9, 10. Okay, this is a list of recommender. And then it goes to the recommender 2. In this recommender 2, maybe from 10, it will be cut down into 5. From 5, it will be cut down into 3, and so on. Okay, so we call this is cascade. Meta level. In a meta level, we call this is the preceding component pre-process input data to build a model for subsequent model component. So when we have a list of recommender system, again, we will extract this data as input. And when we have another input, we will build another model in the recommender 2. So with this, the collaborative knowledge base meta level. Let's see the first one, cascade. The cascade hybrids are based on the sequence order of techniques. This is an order of techniques. So approach technique 1, and then it goes to technique 2, and then it goes to technique 3, okay, something like this, in which is succeeding recommender only refines the recommendation of its predecessor. For example, this one, successor recommendations are restricted by the predecessor. Predecessor means the previous one. So the recommender cascade u, I equals to recommenders n u, I. It is for all k higher than 1. So this is the formula. Subsequent recommender may not introduce additional items. So the items is only 1, and this produce very precise result. Let's see. With the cascade, we can reduce the recommendation list. As I mentioned to you, if in the recommendation 1, we have 10. So in the next stage, we can have 5. And in the next stage, we can have 3, for example. So it will be reduced for every step. So there is a chance that no recommendation be made. So if we have already 10, and then the next, it can be 0. Maybe there is no recommendation. There's a possibility. So cascade strategy should be combined with switching strategy. You still remember switching strategy? Okay. In the switching strategy, let's say if we want to know about the user for the cold start problem. For the cold start problem, for user, we can use the knowledge base, and then we combine with collaborative filtering. If we have the cold start for item, then we can use the content base and then continue with CF. So switch the recommendation with different techniques. So if the cascade strategy cannot give any recommendation, then we need to switch the strategy. So for example, first recommender can only make a recommendation list. So of course, the first one is important. Maybe in the first, we use the recommender base using the knowledge base. The knowledge base recommender produce list of unsorted items. So remove absolute no-go items. It means if the item is not necessary or if the item is not popular, we can remove it. And then the second recommender assigns scores. For example, we can do the ordering or we can do the refinement. So like this one. In the cascade, we have recommender 1 and we have recommender 2. In the recommender 1, we have 0. We have 0. So it means actually it is not recommended by recommender 1 because it is 0. Because it is 0. Then if it is already in the first stage, this is in the first stage. So, okay, this is in the first stage. Because in the first stage is already 0, then just make item 2 and item 5 as 0. We don't care the second one. We don't care about the third one. So we do care only rank number 1, rank number 2, and rank number 3. So check. Next one. Based on this one, rank number 1, okay, we have the value here. Okay, then we do the combination between item 1 in recommended 1 and item 1 in recommended 2. So we can combine this. For item 2, because it is 0, just make it 0. For item 3, because we have 0.3 and here we have 0.4, okay, let's make the combination. For item 4, we have 0.1, we still have value, but here we don't have any value. Then, because it is 0, we call this is ordering and refinement. So we refine according to this order and we can get this one is 0. Okay, then just make it 0. And this one is 0 and 0. Of course, this is not important. So this is what we call as cascade. We check on the first one, removing no-go items like this item 2 and item 5 to make it simple. And then we go to the next, do the ordering and do the refinement. So in the cascade, so there are many works about this one. Let's say, yeah, we want to do the document recommendation. So in 2020, there is one of the papers, document recommendation and feedback collection analysis. Okay. So the first using the collaborative content-based filtering. And after content-based filtering, we want to check the temporal decay and then check the collaborative filtering and then do the final list of recommended document. So it means there are several steps. The first steps, they use this one, rank with the M25 and Jaro-Winkler algorithm. And then in the temporal decay, they use the re-ranking. If you still remember the re-ranking in the first part of our lecture. Okay, we learned about the re-ranking and increase rank of the recent document. And then with the collaborative filtering, we will do the re-ranking with consideration of view and downloads. And then at the end, we do the final list of the recommended documents. If you can see this one, this is a multiple step to make the recommendation system better. The last one is about meta level. Maybe let's have a break. Okay, I will continue for this meta level after the break.